All right, let's kick it off. Hello, everyone. How are you? My name is Apoorva Dave. I'm a team member here at Sysdig, and really appreciate you taking the time to join us today. We're going to talk about some pretty cool things. We're going to do a little bit of slides and then a whole lot of demo. And what I hope we do even more of is answer your questions. So one thing to know about me, I can talk a lot. And I can talk a lot about what I want to talk about, or I can answer your questions. So I would love for you to ask a lot of questions during this webinar. I'll try to answer them as you ask them. If I can't do that, maybe I'll push them off to later in the webinar. Or here's the best part. If you stump me, I'm going to send you a t-shirt. I'm not that hard to stump, by the way. I'm not magical when it comes to this technology, like some of our engineers are, but I know a thing or two about it. So I'd love for you to ask some hard questions. The way you do that is by using the either the chat or the Q&A button in what should be the upper left-hand corner of your window there. So you can try it out right now by chatting into us and telling us how familiar you are with containers. Are you using containers in production? Are you just testing them? Are you kind of fooling around with them as a weekend project? And also, if you're using any orchestration systems like Kubernetes or Swarm or Mesos, let us know that as well. I'm going to take one moment here to let you chat those answers in, and that's going to give us a lot of context to really tune the demo portion of this to exactly the kind of environment you're thinking about and what you're looking at. So great. As we do that, why don't I just do a little bit of introductory stuff here, and then I'm going to stop for a moment and see what kind of answers we've gotten on the Q&A, so we know what kind of environments you have. So why are we here today? We're here because of this new thing called containers, and the fact that containers are really changing the way people build and operate their software. Now, what's been interesting from our perspective is that as you move to microservices and container-based infrastructure, we're typically finding with our customers that those architectural shifts break legacy monitoring and analytics tools. And that's the reason Sysdig was born. That's what we focus on, which is this next generation of technology and understanding how we can technically implement a more robust, more suitable methodology for monitoring, troubleshooting, and alerting these really complex distributed systems. Before I go on, let's just do a quick check here. Okay, cool. We've got Peter, who is using Docker in production with Docker Compose. Awesome, nice work, Peter. I have not gotten any answers from anyone else. So right now, I think the other people on the webinar are confused. They're like, wait, is this the right one? Is this where I should be? If they're not confused, then they're typing in their answers right now to let us know. All right, so let's talk about why, so I mentioned before, a big claim here, you move to Docker and all of a sudden all your monitoring and instrumentation breaks. Why? Is it true? Can it be verified? Here's what we've seen. First of all, legacy monitoring approaches can't see inside containers. That's because the containers themselves built on Docker are designed as a layer of abstraction to make it easy for code and applications to be really portable. The challenge with that layer of abstraction is that it causes the code inside it to look like a black box. Really good for development and for portability, not so good for operations, where you really need to see inside the black box to understand not only how's the container performing, but how's the app inside the container performing. Now, one obvious solution might be, let's run the monitoring agent inside the container. And that on the surface seems like a quick, easy fix, but actually breaks the model of Docker. Docker's kind of architectural model is designed around process isolation. Making each container as lightweight as possible makes it have fewer dependencies and makes it more portable. If you put an agent inside that container, it is bloated, it's less portable, and has more dependencies. It means you may not be able to use a base image off of even the Docker registry. And of course, when you're throwing more and more stuff into a container, you open up the surface area for potential attacks. Never a good thing. All right, so you can't see inside it, can't put something inside it. We got some issues here. Now, let's level up one. Why are you deploying these containers? For many people, they're deploying them because they're trying to build a microservice-oriented architecture. But most monitoring tools don't understand that a microservice-based architecture looks different and should be monitored different and may, impact different parts of your team in different ways. So it's yet another problem you have to deal with. It's a more subtle problem that you'd have to deal with in relation to your existing monitoring solution. So let me take you, so there we're at the 10,000, now maybe the 50,000 foot level in terms of like what's going on with this world. Let's go all the way down to an individual host, the individual kernel running on that host. Let me talk a little bit about how Sysdig instruments systems to help get around some of these problems, and then we'll look at what are some of the impacts of this instrumentation and how it works. And then, by the way, right after I describe container vision, I'm going to stop for questions because there's usually a healthy number of questions around this. Okay, so Sysdig invented this new way of instrumenting systems that we call container vision. And at a very high level, what you do is you put the Sysdig Cloud agent as a container on each individual host. Based on the way we instrument the system, we can see down into the host, the underlying infrastructure, your container orchestration, but we can also see across inside the other containers that are running on that host. Essentially, we can see inside these containers from the outside. This type of instrumentation means that you can deploy a single Sysdig container per host and see everything running on that host. Let's go a level deeper. And hopefully I'll explain to you a little bit better how this works. So take this hypothetical environment. We've got, we've got a Docker container, we've got a Rocket container, we've got LXC running here, we've got a couple non-containerized apps, and they're all communicating to the host. They're passing system calls, and the kernel of the host is trying to pass those off as necessary to the right resources. What Sysdig does when it's deployed is we deploy a kernel module. And by deploying that kernel module, we can transparently see every single system call that every container is making. More importantly, we can see the system calls that the applications running inside the container are making. And from this single point of instrumentation, we can see not only file I/O, we can see network calls, we can see requests for other resources, we can see requests to other containers. We can see everything happening on this host from this single point of instrumentation. In addition, we can see things like custom metrics flowing, whether you're using JMX or StatsD or something similar. We can see those metrics flowing through the system, and we can capture those. What do we do with all of that information? Well, it all gets passed back into the Sysdig agent container, and that's where we collect the data. We do some processing there, and we send those metrics then to our backend. And that backend, of course, is where you're going to visualize that data, troubleshoot with it, and alert on that data. That backend could be running in one of two places. You could either see that backend as a SaaS service, in which case Sysdig is running it and you're passing the data into Sysdig Cloud's SaaS service, or you can run our backend as software in your environment. So that your environment could be your Amazon VPC, or it could be a true private physical cloud data center or anything in between or any mix. That enables you to kind of take the right approach to monitoring that's right for your organization. All right, so I've just explained container vision to you. I've explained how we instrument systems. I would love to stop here and see if there are any questions. All right, so first question came in here, which is, are there any special privileges I need to give to this container? Yes, that's a great question. The Sysdig container runs as a privileged agent. A privileged container. We need to be privileged in order to install our kernel module on your host. If you're not running containers and you'd like to instrument your system with Sysdig, you can do that as well. As indicated in this particular diagram, you can certainly see everything coming from non-containerized apps as well. In that case, you simply run the Sysdig agent as a root process on the host. Bay also asks us, how is the installation process? It's crazy easy. It's so easy, in fact, that I'm going to show it to you during the demo. And I think that that's pretty unique. You probably don't have too many monitoring analytics tools where someone's going to say, hey, let me show you how to instrument your entire system before I show you, all the pretty graphs. But we've massively simplified that install process, and I'm going to talk about a little bit about that when I talk about application auto discovery, which is a pretty cool thing we do during that install process. Other questions? Questions, comments, concerns? Okay, well, let's keep going. And if we have any other questions, feel free to fire them off at me. All right, now, great. So we've instrumented the system. Our claim is that now we can see inside these containers. I still have to prove that to you. I know that, and I will do that during the demo. Once we do this instrumentation, I think that you'll see that we actually can give you better visibility than you've had in the past. And part of it is this unique instrumentation capability. And Bay has also asked, is Sysdig the only company that has this architecture? To my knowledge, we are the only ones who have this architecture focused on container monitoring. Makes us very unique. And it's a lot of the reason we're getting so much traction in the market right now. Once you have that instrumentation and that architecture, you can actually see much more than infrastructure-based monitoring and alerting. You can see what we think of as these 3 layers of visibility into your infrastructure. First off is service-oriented performance management. So in the old world, you were thinking about a host, and you could very quickly and easily relate that host to an app. That's not the case in dynamic distributed container environments. So instead, we think about aggregating container information into service information. So you can say, how's my billing service doing? How's my database service doing? And we'll go into that in more detail. Application intelligent monitoring and alerting. So not just monitoring your infrastructure, but monitoring the application that's running on top of it with application-specific metrics that we can automatically pull. And finally, trace-driven troubleshooting. Most monitoring tools give you a nice graph and can alert when that number looks like it's off, but they're not particularly good at letting you dive deep into your environment to see what's actually happening. We've changed that around. Let's start with the first one, service-oriented performance management. So when you've deployed a containerized set of services, and especially if you're using an orchestration system to manage those containers, it's not very easy to relate the underlying infrastructure to the containers running on top. This is a simple example where we've got these 3 services, and we've got Kubernetes, a Docker Compose, or something similar, orchestrating those containers across those hosts, and they're spread out. If you wanted to answer the question of how's service 1 doing, that would be really difficult in this environment, right? Like, would you be able to tell if you're seeing performance drift on that service? So we want to solve that problem by giving you basically a on-demand lens that you can look through and say, okay, give me a service-oriented view of my performance right now. And so you could answer questions like, what's the response time of my Cassandra service? It's currently distributed over 3 data centers. And more interestingly, what are the slowest queries? Do I care about those queries? This is a particularly hard thing to do, especially when you've scaled up a container environment. The way we do it is through deep real-time understanding of orchestration metadata. So what we do is we integrate with your orchestration system. So, Mesos, whether you're using just the raw open source Mesos, you're using DCOS, Docker, if you're using basically anything from the Docker stack, whether you're just doing raw containers with labels, you're using Compose, you're using Swarm, you're using UCP, we're comfortable with all those technologies, and Kubernetes as well. We're very comfortable with that language. In addition, we allow you to collect label information from your underlying cloud providers as well, and that's another way we can kind of understand the logical blueprint of your application and not just the physical blueprint. I'm definitely going to show this off in the demo, but another good place to ask for questions in case you have them. While you're writing those in, let's talk about how we get intelligent about the application as well as the infrastructure. We start with this concept of automatic discovery. And, I think you're probably all too familiar with the fact that you need to typically, when you're setting up a monitoring product today, you have to tune those agents to know what applications are running on the host that they're monitoring and what are the correct metrics to collect. We've automated all of that. Through our unique instrumentation, we can actually see the system calls that a particular app is making, and by using that data, we can determine what application it is. When we determine the application, we can start polling it for appropriate application level metrics. So I'm not talking about CPU, memory, and disk. I'm talking about cache hits and misses. I'm talking about response rates, connections, error rates, response time, and so on. The next thing we do to make this as automated and simple as possible is once we've auto-detected those applications, we already have pre-built templates for dashboards that allow you to see that application instantly. So imagine it, we drop an agent onto a server and we find the containers, understand the services. When you come into the back end to view them, or the app to view them, you automatically have a view of what that app is doing. Similarly for custom metrics, statsd and JMX, no agents inside containers, no reconfig. You don't even have to point your statsd or JMX to us. We'll automatically find them. And finally, we do anomaly detection so that we can help you determine what looks abnormal. And that's a simpler way to start looking at your application versus having to pre-configure all of your alerts. Bay is asking how we do anomaly detection. It is over historic data. It basically uses an algorithm we developed to create an envelope of normal or predicted behavior in a particular set of metrics, and then we can alert you based on that. So there's a little bit more on that in our documentation. The historic range. Bay, good question. Is the historic range fixed? Yeah. So our algorithm does use a kind of a rolling window that goes into the past, and it is fixed. We don't offer options yet to let you tune that. So this is a slide that I affectionately call Logo Soup. This slide is just showing you all of those pre-built app discovery capabilities we have today. I'm going to take a moment here for you to look at this and see what's relevant to your environment. Let me say a couple things here. So first of all, we're continually developing new application auto discovery templates. So check back frequently. We add more all the time. You can also customize this. So if you're, if you've developed a custom app and you'd like us to pull it for information, then you can write a simple script that goes along with our agent, and we'll do that. And here's the cool thing here. Once you've written that script once, it gets deployed to all our agents, and then we'll auto-discover your custom application. So there is some one-time work for a custom app, but from there on out, we can auto-discover it. And finally, as I mentioned, with statsd and JMX metrics, if you use those out of your custom apps, we'll collect those automatically. Final point here before we get to the demo is trace-driven troubleshooting. So, okay, so you're all used to this. You've seen the chart that's going up and to the right or down and to the right, either one indicating a problem, and your alert has fired. So that's good. You understand there's a problem at least. But how do you dig in? How do you actually go see what that problem is? Usually what happens is once your monitoring tool tells you there's a problem, then you go in and SSH into a host. You're running commands like top and netstat and so on to figure out what's going on this host. Maybe you're grepping through logs. It's messy, it's complicated, it's necessary, but we wanted to simplify that. And the way we do that is with this thing we call a capture file. So capture allows you to record every single system call that was happening on a host when an alert was fired. And from there, you can use either our app or the open source Sysdig command line tool to analyze the system calls and see what was really happening on that host. The cool thing here is, of course, this is a kind of more of a permanent record. So if you can imagine your orchestration system coming around and killing off containers, moving containers around, you may not have a record of the state your application was in when that alert fired. But with the Sysdig capture file, you absolutely do. You have the ability to troubleshoot containers even after they're long gone. Just a question for the audience here. How many of you are familiar with the open source Sysdig tool? All right, cool. It looks like a bunch of people are familiar with the tool. If you haven't used it before, go to www.sysdig.org, grab it. It's an incredibly powerful tool for troubleshooting a host. All right, so we've covered 3 things so far. So let me just circle back with this example here for trace-driven troubleshooting. Replay the state of my system last night when the off alerts fired 5 minutes before our app went down. Show me all the system calls from the containers we destroyed. Imagine doing this with a monitoring tool you have today. You just really can't. People haven't really created this ability, and so it's really powerful. Okay. So we covered 3 core capabilities here from this instrumentation. We've covered service-oriented performance management, seeing what the service is looking like. We covered the ability to simplify dynamic monitoring processes, and finally, you can dig deeper into what was happening at the time of performance. Bay is asking another great question, clarification there. So you get alerted on troubling stats, then you automatically get a summary view of the last 5 minutes before something happened. Yeah, so you can do a couple things. So take away the specificity of the last 5 minutes for a second, and once you get an alert, you can go back in time and see what was happening at the time that alert happened from the perspective of your monitoring metrics. And then you could drop down into the actual system calls that were firing at the time that alert triggered, and you can do much deeper troubleshooting. And I'll show you, I'll give you a glimpse of that during the demo. Okay, so here's what I want to do during the demo. I want to show you how to deploy a Sysdig agent, and I'll show you the instrumentation. We want to cover service-oriented performance management metrics and analytics, show you a deep troubleshooting example, and basic monitoring. Okay. Now we see, finally, we want to just show you some basic monitoring stuff. Also got a great question on how is Sysdig different from some other technologies in the space, and I'll cover those in a little more detail once we get through the demo. So give me a moment here. I'm going to stop my share, and I'm going to switch over to my demo environment and make sure everything is still up and running as I left it right before I started the presentation. All right, and make sure I've got a terminal window up. Okay. Share screen again. Great. All right. Can I get an amen from the audience if you can see my demo environment here? You're looking at Sysdig Cloud. Great. Thanks, Bay. So far, Bay, by the way, is crushing it in terms of audience participation. He's my man. He's really rocking it. So thank you. Okay, here we go. So what we're starting with here, what I'm showing you right now is a pre-existing demo environment where we're going to go back and we're going to do a lot of deeper analysis. It's a Kubernetes orchestrated environment, and Peter had mentioned he's using Docker Compose, and this would work very, very similarly because we out of the box understand metadata for Kubernetes. We understand metadata for Mesos and Marathon and DCOS. We understand metadata from raw Docker container labels or any of the infrastructure built on top, like Compose and UCP and Swarm. What this enables us to do is give you some different views on what is going on in your infrastructure. So let's start, in fact, with a physical view. And this physical view is showing you the actual hosts in this environment. So we're looking at a few things here. We're looking at a few different core hosts, and we're looking at some Amazon services that we have not instrumented. This is, I guess it's an interesting view. I'd say the most interesting thing here is this was all dynamic. You didn't have to provide us with any additional information other than instrumenting your host to see this. But in reality, it doesn't tell you anything about the containers you're running, nor does it tell you about the services. One cool feature we have here is we allow you to treat this like a map. And the folks at Google like to call this Google Maps for your infrastructure, which is you can dynamically zoom in here to see the containers running on each and every one of these hosts. So that's pretty cool. I can get not only the containers, but if I keep going, I can get down to the individual processes running in these containers. This is entirely configurable. So here we're looking at CPU. You can look at memory or a number of other characteristics. And similarly, you can see that the lines between these containers allow you to look at information like response time and request time. You can look at bytes transferred and so on. As I mentioned, this was a Kubernetes environment, which means we can then use Kubernetes data to, in fact, create a logical view of our system. Now, I'm not really concerned about where the hosts are and what containers are running on those hosts. I care about the services that we're running. So here you see we've got multiple namespaces, prod and dev. Let's go focus in on prod and zoom in here. And from here, what I'm looking at are actually deployments. So using the Kubernetes metadata for deployments, I can drill in and see, oh, okay, this makes a lot of sense. I've got a WordPress application writing back to MySQL. I've got this custom Java app, which is writing to these multiple backends. You can see you can hover on this to learn more about the node hierarchy, the metrics, and we can go and explore further. We won't do that just yet. And once again, we can keep drilling down here. So we can drill down from the deployments into the replica sets, into the pods, into the individual containers. It's a really powerful way for you to start viewing your system and understand the relationships between these components. Again, this is all dynamically done. And part of what we do dynamically is instrument your master and collect the relevant metadata for that master. So we've simplified this process so that these views are always up to date for your systems. Now, you may be asking yourself right now, great, can you actually show me how you get this data and what it looks like? So in order to do that, I'm going to hop over to a different demo environment. And this is my personal trial environment. You can see here, I've got that bar is telling me this is a trial environment. This is my Apoorva account. Cool, but this is a very sad environment. It's incredibly sad because it's got no data flowing into it. And what good is an analytics tool with no data flowing in? Let's fix that. Sorry, let's go to my terminal here. I'm running a very simple environment in Amazon EC2. As you can see here, I've got a few containers running. I've got a simple app running WordPress and MySQL. This is my personal AWS server, so I also run a Sysdig Slack bot on it. That's something pretty cool that we invented to do some work with chat ops. You should check out the Sysdig Slack bot if you have a chance. All right, so we want to instrument this system so the data is flowing into Sysdig. Come back here. Let me show you our settings environment. And we'll say, well, I need to install an agent. We have multiple install methodologies. We've got this Docker container. We've got this very new, very cool two-step GKE install in case you're interested, and CoreOS and raw Linux install. We're going to use this Docker command to install the host. Now, I already have kernel headers set up on this host. If it's your first time, it's a raw host, you will have to run one of these commands in order to install kernel headers. And let's go over here. I'm going to run this command. Great. And now what's happening is Docker is pulling down the most recent version of the Sysdig agent. It's installing that agent. And now what you'll see as it installs the agent, it's going to automatically start looking for, Docker. It's going to start looking for the orchestration systems, and it's going to start collecting the system call data and passing it back as we discussed in the early part of the presentation. Now, what's cool here is this methodology for what I've shown you is all we need to do in order to collect information about the containers, auto-discover applications, and auto-collect custom metrics like StatsD and JMX metrics. If I hop back into this environment, we're going to go to a different place in the environment called the Explore table. And what you see in this Explore table is the host we've instrumented. There it is. That's cool. Now, the Explore table is kind of like top for your entire distributed infrastructure. So not only can you get this host and you see basic information like CPU, memory, and disk, you can drill down and, oh, look at that. There are all my containers running. That's cool. Now I can get container-specific information. Let's go one step further. This one is cleverly labeled MySQL. So what happens when I click on MySQL? First, I get an overview by process for MySQL. This is useful. Actually, let me just expand this. Let me use this for the whole screen here. We can see that we are getting detailed information about MySQL. We can see exactly where we started up the instrumentation. Let's do this, however. Let's search for MySQL in terms of views. And you can see here, I can click on this MySQL or PostgreSQL view, and now I'm getting application-specific metrics. I'm not getting CPU, memory, disk. I'm looking at average and max request time. I'm looking at top queries by numbers of requests and top tables by requests. You can also see slowest queries and slowest tables and request types over time. So we're giving you the ability with your simple single instrumentation command to not only see the host, not only see the containers, but also see the applications running inside the containers, and metrics that are critical for each and every one of those apps. So much like we're looking at slowest queries here for MySQL, we could look at relevant response codes and error codes for your HTTP service, and so on and so forth. And I'll show you a little bit more of that in the more complicated environment. This is a good place to stop and see if anybody has questions specifically along the lines of the instrumentation that we're doing. All right, so in case you do have questions, feel free to fire them in, but now we are back to our slightly more complicated Kubernetes environment. All right, so let me show you a bit more here about what you can do in this environment. We'll start with some information here on service performance. So, of course, this is a system that offers robust dashboarding, and I wanted to just give you a quick example of a dashboard here that you might create for your web app service. And here what you can see is we've got everything that's critical for our web app service. We understand request counts, error counts, request times. We're looking at top endpoints by request, slowest endpoints. We have a topology that we can use similar to the ones we were looking at before. And we've got powerful charting capabilities that give you a little more information about what's going on. Similarly, we can correlate events to these metrics. So let me establish a longer period of time here and decide maybe we only want to look at alert events. Well, should be getting some. Oh, the system has been doing really well. We don't have any alerts running right now. We'll come back to that in a different view. We do have the ability to correlate events with our metrics, and we'll show you that in a second. Let's hop over to the Explore view here. Now that we have a more complicated environment to look at, you can see some interesting things here. So first of all, you've got our multiple hosts, and just like before, you can see the containers that are running on top of them. You can see that you can set up color coding for the Explore table so that you can automatically be alerted to things that look off, like, oh, wow, this is running at 95%. That's not my normal range. That looks like an issue. In fact, the truth is our demo environment rarely runs at 95%, so I'm definitely going to be digging into that afterwards. All of this is fully configurable, so you can delete these columns, you can color code these columns, you can decide how the data is aggregated here. You can also add more columns here. Now, the cool thing here is we've pre-built views that allow you to see different slices of your infrastructure. And the way you can really access that is by using this grouping function. And so the grouping function allows you to apply different metadata to show a different slice of what you're looking at. So we were looking at the hosts and containers view. Now I'm going to use the Kubernetes deployments view. And in fact, let me start over here. And I should have done this on the overview panel. And let me just describe a little bit about that grouping functionality. The grouping functionality gives you the ability to arbitrarily group based on any metadata in the system. So here we're using Kubernetes data. You could easily, can comfortably mix Kubernetes data with Docker label data with AWS data to slice and dice the system however you'd like to see it. We've pre-built other views like container limit views. So for example, let's suppose you're not interested in knowing the CPU of the host, but you're more interested in understanding what percentage of CPU shares that were allocated to a container are being used. And here you can see that based on the environment, getting down to the containers, getting down to the services and the containers themselves. You can do that similarly with memory. A new one we've added, truth be told, this is my first time looking at this new one, is actually a service-oriented view. So I could drill down on prod and get basics for this service overall for no matter how many containers it's running across. So you see a container count, and this is averaged over time, which is why this is a half a container. You're looking at requests, average request time, and max request time. Again, a quick and easy way to assess how is my service performing? How, is it really doing what I expect it to do as an aggregate service and not as an individual container? All right, I'm going to go back to the overview panel here, and now I'm going to start drilling down deeper. As we talked about before, you can click on any row in this table and get a deeper view of what's going on. Let's start by clicking on the prod environment. And in the prod environment, I want to take a service-oriented view. So what I'm going to do is look at these services, and I'm going to look at an overview by service. So now, this view is giving me a very much like Kubernetes-oriented view in terms of what services we may see in this environment: container counts by image, request time, request counts, CPU, container limit usage, memory usage. You can see in this count, like this one, we've got a container that has a huge spike in request time. So we may want to, drill in closer. If I zoom this, I can get a little bit better view, and I may want to go do some work to go figure out, well, why did this thing spike, and should I be concerned about it? All right, so let's drill in further, and let's say that I was interested in looking at this Java app. And now what I want to do is I want to look at a service overview so I can look at the particular elements of this service. And again, these are high-level metrics that are relevant to this particular service. Again, here I see this interesting spike. So I may want to dig in further. Because I do know this is a Java app, I may want to take a look at Jvm Oriented Metrics. So I can click here on Jvm, and now I'm getting heap usage by time and process. There's usually garbage collection time and collection count. We don't have any data for this demo environment. That's why you don't see it. And we also see thread count here. Now, if that's not enough for you, in fact, we actually have more metrics in the system that we're not showing in these pre-built dashboards. So you can come over here to the metrics component, and you can see all of our metrics that we have in the system. And you can click on any of these to get an individual time chart, which you can further analyze. So you can do segmentation by container ID, and you can see how are things varying among container here. Similarly, this is a good place to look for things like JMX metrics, and I won't run through all of these, but you can see here that we have them. And then finally, stats D metrics. Similarly, you can have as many metrics as you want. So what I've shown you so far is the ability to get from this high-level view of your prod environment, understand the services, drill down into an individual service and understand what's happening with that service, and then get into app-level metrics and app-specific metrics that are relevant to whether or not you're using a custom Java client, whether you're using something like a MySQL container. Similarly, we have incredible views for almost anything. For example, like Redis here, we can go into the views and look for our pre-built Redis view and see, again, things that are very specific to how Redis is performing. Finally, one other very common thing, which is an HTTP service. Let's look at HTTP. We can get an overview of our HTTP service with requests, errors, request times, top URLs, slowest URLs, error codes, and so on. So a robust system that gives you kind of full visibility into your system. Because we had one more question is, what kind of network data do you have? That's a very good question. What's really powerful about our instrumentation approach is we can not only see the app, but we can see the underlying network as well. So as I search for network in the views here, you can see that we have a number of different networking views here, connections tables, response times, and top ports. Let's click on the connections table to give you a sample here. You can see each of our physical endpoints and the remote endpoints and data about the, about the performance of those endpoints. And the overview will give you a slightly different view here, which is the kind of a more complete view of everything across the networks, the ports they're using, the bytes that are being transferred, and kind of give you a great starting point for deeper analysis. All right. So we spent a lot of time talking about Explore. This is a pretty unique way of using a monitoring product. While you're using this Explore view, by the way, you can grab any of these and pin this panel to a dashboard. I won't do it here, but you click on there, and then you just basically say, like, okay, do I want to use an existing dashboard, or do I want to, do I use an existing dashboard, or do I want to create a new one? Great. All right, so let's now talk a little bit about alerting. That's the only thing we really haven't talked about in detail here. Just for the purposes of alerting, we'll go over here to my Mongo dashboard. There we go. And say, well, let's suppose we want to create an alert here and we want to do something based on request count. We can click here and we get this, you see this alarm bell in a lot of places in our app, and that's how you add an alert. Now, what's unique about our alerting capability is the ability to do service-based alerting. Service-based alerting means don't talk to me about hosts, don't talk to me about individual containers. Let me tell you what service I care about, and then create an alert that will operate on that service no matter how dynamic it is. And in this case, what you see is we've used our metadata to say, give me an alert for the prod environment and the Mongo deployment. Here you can set a manual condition or use the baseline anomaly detection algorithm we talked about earlier, or a host comparison algorithm. You can set a metric and a condition. That's pretty standard. What's more interesting is if you switch to advanced mode, you can actually use Boolean logic in your alerts to say, not alert me on multiple conditions at the same time. And we have a convenient metrics dictionary here that allows you to select absolutely any metric that you're using. One other interesting element here is the segment capability. So you may have a very large service that you want to segment in different ways. For example, imagine you're running a service across multiple availability zones. You may want to segment it by availability zone. So instead of getting one alert on your Mongo service, you may get multiple alerts. One for your Mongo service in AZ1, another for your Mongo service in AZ2, another alert for your service in Mongo AZ3. We can do that in another way, which is, well, what if I care about Mongo running in prod and Mongo running in dev? So I'll get rid of prod from the scope here and say, instead, segment by Kubernetes namespace name. So now what I've done is I've essentially said anywhere there's a Mongo service running, give me one alert per namespace. So I've essentially created two alerts in this case, one for our dev and one for our prod environment. You can set filtering conditions, and finally you can set the window for the alert. So the minimum window is 1 minute, and you can specify how that works. You can call the alert something. You can even spell it right if you're capable. And select a severity. Finally, you can configure notification channels. And we have a ton of notification channels that you're able to set up. I will actually hop over in a moment and show you all of them. But you can do Slack, email, PagerDuty, VictorOps, and as of yesterday, you can also use a generic webhook output. So you could trigger another part of your system to take action when something goes wrong in your environment. Okay, finally, you can trigger a Sysdig capture on an alert. And this is that critical part about trace-driven troubleshooting that we were talking about. What happens here is that when you enable this, your alert will trigger Sysdig to trigger an alert, trigger a capture on the particular affected hosts. You can set a time frame, so for how long you'd like that capture to run, and you can also set a capture filter. And if you're familiar with the open source Sysdig tool, you understand that it has a robust filtering language that would allow you to choose exactly which events you want to see. For example, you may only want to see events where a process is being killed, or only want to see events where a process is using a particular resource. That's all possible within Sysdig captures. All right. So now let's just say we've created an alert. I didn't actually create that alert, but all your alerts would be listed here. And more importantly, when an alert fires, it creates an event. Sysdig actually collects two kinds of events today. One is an alert event. And so you can see here that we have a number of alerts that have fired in our system. And two is a custom event. And a custom event is pretty much anything that's relevant that you would want to post to the system. So typically, we see a number of types of custom events. So first of all, out of the box, we collect relevant Docker events and relevant Kubernetes events. And so you can see here, we see things like you were scaling a replica set, killing a container, so on and so forth, pod deleted, container killed, so on. Now, we also can collect anything you'd like to post to our API. Those could be CI/CD events. They could be code commits. As you can see here, we've got some Jenkins events that we're rolling in via our API. And as I mentioned earlier, we have a Slack bot that can listen to any channel and post events back to our system. So you can tell, you can let Sysdig know if you've had a bad day. You can let Sysdig know if you haven't had enough coffee today. And those things may impact your system. So let's go explore one of these events. Let's see what happens here. And actually, maybe what we'll do instead of just exploring it from here is we'll actually imagine a little bit more of a complete workflow. Let me go to back to my demo environment here. And here what we're looking at is our Slack channel, where we're seeing alerts that that have fired in the past. So let's look at an alert we think might be interesting here. We have this low connection, dev low connection on MySQL database just fired. Let me view this notification. it's going to pop me back into Sysdig Cloud, cleverly opening up a new window for us. And here's the alert. And you can see it brings us right to the alert. It gives us this quick overview of what happened at the time the alert was firing. And now we can explore the event. Bay, this is relevant to a question that you asked. So now what this is doing is it's taking me back in time through my entire infrastructure to see what events were happening at the time the event, at the time this happened. Now I could scroll through my entire infrastructure here to see what's going on. So for example, we see this poor performance in our environment. We see these alerts firing. My first question might be, well, okay, this is happening in dev. Is this happening in prod as well? So let me look at MySQL across the board and then segment by my namespace. And saying, oh, okay, well, look, I'm seeing this. And right now, it looks like it's happening across prod and dev. I'm in trouble. I also see that this did recover over time. Okay, do any of these other events help me understand what's going on? So one thing I see is we had this performance issue appear at the time when Jenkins started this WordPress deploy. And then there looks like there are events here where, okay, well, we're scaling a replica set and we see that Jenkins rolled back. And so clearly the team had seen this problem, had committed some code, rolled out new code, seen the problem, and then rolled back. So you can imagine a world where, you know, that the rollback hadn't actually happened, and just having a specific view into this section of your environment would have given you the ability to see that this code rollout created part of the issue that you were dealing with. So this ability to deeply look at alerts, go back in time to see your metrics, correlate them with events, gives you the ability to go really, really deep in terms of troubleshooting. If you wanted to go even deeper, you can, of course, use the Sysdig captures we mentioned. Here you see a list of all the Sysdig captures we have, and clicking on any of these gives you a deep view of the process, the information on a process level that's running. This is a ton of information, so sometimes it takes a while to process, but you can see here a simple tree map using the data of CPU usage segmented by process, process ID, and then process arguments. So if I'm interested in looking at this, I may be interested in looking at, for example, this process, and then segmenting it by process name, process ID, and then I could click in it to see if there are any process arguments running. If that's not powerful enough for you, you can also use tools like Sysdig. And this is our open source tool. Pardon me. That'll give you a real-time view into all the system calls running on your machine. You can use this in real time, or you can use this in a capture mode, which is showing you that file that was captured at the time the alert was fired. We also give you the ability to look at particular views that may be relevant for you. So for example, we could take a container-specific view here and collect data, and you can see those containers running, and I could drill down into any one of those containers to see exactly what's happening with those containers. All right, so I'm going to step away from that because that's pretty deep, really useful, incredibly powerful for you to troubleshoot, and an ability most monitoring tools will not give you. We went all the way from looking at a service-oriented topology of our environment down to individual metrics, correlating alerts, and getting into individual system calls. All of this was done from a single point of instrumentation. That's what's so powerful here. This single point of instrumentation can understand your system to a depth that other systems simply couldn't do, and in a way that's relevant to containers and the microservices that run on top of them. That's pretty powerful. It's unique in what we do, and I'd love for you to give it a try. There's a few different ways you can try this. You can try our SaaS service, which is Sysdig Cloud, starting at $20 a month a host and discounted for larger server volumes. You can use our on-premise software, which means you run the backend yourself. All of the features are the same, but we only do this on an annual basis. And finally, you can use the Sysdig open source tool. It's a CLI-based troubleshooting tool. You saw it at the end there. It's used for troubleshooting a single host, and it's supported by the community at large. Talk is cheap. Demos are a little bit better. Nothing beats your own trial in your own environment. If you go to sysdig.com, you can start a trial yourself. You can start seeing service-oriented performance management, our level of application intelligence, and trace-driven troubleshooting all the way down to a capture file across all your containers, all your hosts, all your applications. It's almost magic. It's the most interesting monitoring tool you will have seen in a while. That about wraps up the prepared part of my presentation here. I would love to answer some additional questions for you. Starting it off right, he's asking if you can see the historic average value for setting the alerts. Yeah, you can absolutely go back and see historic average values. You could either get a time chart of it, or you could see it as an individual value. So for example, if I hop back here, I go to my dashboard. Let me just choose one that maybe like this web app one. Let me pull up this web app dashboard. Okay, so these represent an aggregation over the time period we're looking at. So for example, if I wanted to see the average value of request count over the day, that's what you're seeing right here. You could see max value, you could see minimum value, you could see the max value across a group of hosts or containers. You can do all of that. It's a great question. What other questions can I answer for you? All right, so, oh, great question from Peter about how monitoring metrics from batch or short-lived applications. Absolutely, you can do that very easily. What you would see simply is, what you would see simply if you're doing a short-lived view is that you would, again, go back in time to where you'd like to see that short-lived view. So we didn't really do any of our time navigation in depth here, but you can go back and see metrics from those short-lived containers. Now, here's the beauty of our system is that we collect your data forever. So we will have a large view of those short-lived applications or processes stored in our backend for as long as you need to. The only thing that you need to note is that we do aggregate this data over time. So for older data, you will typically aggregate that into kind of longer periods of time. Bay asked the question of what's the best way to see what services are problematic from the dashboard view. So you certainly can create a dashboard around anything that we've seen in the Explore view. So for example, here, we're looking at a web app service. And so this is a good way to assess how's my web app service doing according to what I was interested in. The other way you could do it is say, well, what if I just had an overview of my services from, say, a Kubernetes perspective? So here, I could look at things like request count by service. You could easily see if something has variation. Top services, top namespaces, utilization, and slowest resources. So again, you could look across your services to understand your slowest resources. You can really be flexible in creating dashboards because you can also create these in a full stack view. So you can include everything from custom metrics to app metrics to network metrics to file storage metrics all on one dashboard. And Bay wanted specifically to know about the logical map view in particular. Well, so what you could do on the logical map is you can color code anything on the logical map as well. Let's put this in real time here. So anything here, we can edit this. Pardon me, a second here. All right. Set this. We can edit this panel. And you can see here, we can configure exactly what we'd like to see on this map. And when you configure this, you're essentially saying, well, what is the core thing that I'm interested in looking at to look for problems in these particular services? So this is a quick and easy way for you to really get down into a service-oriented view from the map and view what's going on and where problems might be. I'd also highly recommend setting up alerts across those various services that you're interested in so that the system can inform you versus you simply having to look at a map all the time for those problems. The other important thing about maps that are valuable is if you see interactions that don't look normal. So this takes a little bit more of your own personal knowledge of the system, but you can see here we have a very kind of smooth and common flow to how data is flowing through these services. If that breaks up and you start seeing strange things appearing or strange lines disappearing, you start to know something's wrong. All right. Last chance for any final comments, questions. Thanks so much, everybody. I would love for you to start a trial on your own. It's very, very simple. You saw me instrument the system, and you can do it yourself. One last thing, we do this webinar every single week, same time, same channel. I would love for you to invite anyone else who you think it might be interesting for, and we'd love to provide them the information that they need. Thanks, everybody. Have a great day.